This is Captain Ross with 3B's Captain School, and this is our Speed Made Good video in our navigation series. Navigation, the art and science of directing the movements of a vessel safely, confidently, and efficiently from one location to another. Speed Made Good, our objectives for this video. State how Speed Made Good is used in navigation. Plot and properly label the latitude and longitude for beginning and ending points. Demonstrate how to connect the points and draw a line with the parallel ruler. Demonstrate using the dividers to measure the length of the track line in nautical miles. Demonstrate how to use time, speed, and distance formula to calculate the vessel's speed made good. So what is speed made good? Speed made good is the actual speed measured in knots. And remember, a knot is a nautical mile per hour. A vessel traveled from one point to another. So in this video, we're going to use this problem. At 2020, you're in position 36 degrees, 50.02 minutes north, 75 degrees, 56.8 minutes west. At 2120, our GPS shows us in position 36 degrees, 54.28 minutes north, 75 degrees, 42.75 minutes west. What was our speed made good? All right, so first thing we want to do, just like course made good video, is plot the starting position, latitude, and longitude. So remember, at 2020, we're in position 36 degrees, 50.02 minutes north, 75 degrees, 56.8 minutes west. So to plot this position, one thing to pay attention to is you can see our 3650 is labeled for us right on the chart. That 0.02 is just a hair above this 3650 line, because remember, 0.02 is 2/100ths of a mile or a minute, not 2/10. So if I was to use these little dashes here, there's 10 of them between 3650 and 3651, which would be right here. This is not 2/10, which would be this line here my cursor's on. This is 2/100ths, just down here. So reality is we're just using this line right here, this latitude line that's already indicated in the chart. And then next we want to do our longitude. And if you looked at this photo here on the right, we'll zoom in on that. So that position, if you see, I've got the dividers, the pointy end here on the longitude line at 76 degrees. And then I've got the lead end of mine, or second point, depending on how you set your dividers up, here marking the longitude that's our position. And then I'm just transferring that up, and I find that it's right on this buoy up here. And this buoy is the safe water mark for Rudy Inlet. So my position, my starting position for this problem is going to be that buoy. All right, then I want to plot the ending position, latitude and longitude. So here I've got the ending position, which is 36 degrees, 54.28 minutes north, 75 degrees, 42.75 minutes west. On here, you can see I've got the latitude I'm measuring out, 36 degrees. Here's 50, 51, 52, 53, 54, and then 0.1, 0.2, and there's 0.3 up there, and I've got my dividers pointed to right between the two because it's 0.28. So I'm almost touching that 3. But that's how I get my measurement for my latitude. And then my longitude, here's a 75-40 longitude line, and that line runs all the way up the chart, so I'm going to use that to measure from. And then the position is 42, so I go 1, 2, 75, There's 2 right there, 42, 42.5, 0.6, 0.7, and then I'm just between the 0.7 and 0.8 to give myself that 0.75. When I move those positions up on the chart, it's going to put me on the buoys that I was talking about. So it's putting me on, sorry, I'm trying to get a pin here. It's putting me on that Rudy Inlet buoy here on the left side. And then on the upper right-hand corner of this chart, you can see in the presentation, I'm circling, it's the Chesapeake light. So those are my 2 positions. And then I'm using the parallel ruler here to draw a straight line between those 2. All right, now I've got that line drawn and I need to measure that distance. So I've connected point A to point B with a straight line. I want to measure the distance between the 2 points. So when I put my dividers on there, I could tell immediately that it was going to be greater than 5 nautical miles. I don't like to use the dividers to measure more than 5 nautical miles at a time because it's kind of hard to keep it accurate. So what I like to do is for distances longer than 5 nautical miles, I measure out 5 nautical miles on the latitude scale with the dividers, and then I walk the dividers along the track line and just count how many times I'm measuring off segments of 5 nautical miles. So for this problem, let me get my pen again here. I start off starting right at the buoy, right here, and then I'm going to measure the first 5 nautical miles. And then I'm going to pick my divider. I use a lead on the end of my divider, so I make a little mark there. And then I start at that mark again, measure the second 5 nautical miles. You can see where I'm highlighting here in that second picture. And then to end it in the third picture on the right, it's less than 5 miles. So I just bring my dividers in till I've got the left divider or the point right here on that last hash mark I made previously here, and then I squeeze them in or use the little worm gear on them to get it lined up right on top of the ending point, which in this case is at Chesapeake light. So it's going to give me 5 nautical miles plus 5 nautical miles plus whatever this distance right here is. And when I added those together, it ended up being 11.9 nautical miles. So my distance was 11.9 nautical miles. Now we're going to compute the speed using the time, speed, and distance formula. So just to review our problem, at 2020, we were in the position that we plotted earlier. At 2021, we were in that second position, and then we drew a line between the 2, measured the distance, and now we're going to compute this time, speed, distance. So the way I like to do the time, speed, distance is to convert the time to minutes. So remember, we're looking for the speed. So the first thing we need to do is get this time computed into minutes. So let's take our military time. We're taking 2020 from 2021 to get the time that it took us to travel from point A to point B. So when I subtract them, remember I put that line down the middle to kind of keep my minutes and hours separate. This one's fairly easy. 20 subtract 20 is 0. 21 subtract 20 is 1. So I end up with 1 hour. So the next thing I like to do is take away that hour from the hour side and transfer it over to the minute side. That's where you see that 60. So it took us 60 minutes in this problem to travel from point A to point B. The next thing we want to do is we've got our 60 minutes, we've got our distance, so now we have to figure for speed. So let's go over this. Speed equals, I'm just going to point to it here. Speed equals distance times 60 divided by time. So we'll take our numbers here. Speed equals 11.9 times 60 divided by 60. Speed equals 714 divided by 60. Speed equals 11.9 knots. So our speed made good in this problem was 11.9 knots. Now this one was fairly easy to compute because we traveled for 60 minutes and we went 11.9 nautical miles. And remember, a knot is nautical miles traveled per hour. So if I was traveling for an hour, my distance is going to equal my speed because I've traveled for 1 hour, and we measure speed in knots. And a knot is a nautical mile per hour. This concludes our Speed Made Good video and our navigation series. Please check back with our YouTube channel for our other videos.